Question that we're going to be solving is question 2. It reads, what mass of NaCl are dissolved in 152 milliliters of the solution if the concentration of the solution is 0.364 molarity? Okay, so I want to remind you something before we start, that M equals molarity, which equals moles over liters, which is also equal to moles times liters to the negative 1, which again is equal to moles times 1 over liters. Okay, so just keep that in mind. For future references, for future problems, maybe even for this problem, this is important. Remember this relationship between these equations. Okay, so back to the original problem. So the first thing we should do, always, is figure out what we're trying to find. So N equals the mass of sodium chloride. Next we should state our given. So what they gave us was a volume of 152 milliliters and a molarity of 0.364. Alright, now remember that molarity is just moles over liters. Okay. So, what we're looking for here is the mass. Check the information given to us, and we find that we're missing information. Mass, as far as solution concentration problems go, it will usually be in grams. So we have some work to do in order to find our mass, but that's fine. We have all the information that we need to do it. So the next thing that we need to do is find our molecular weight of NaCl. So first we state the atoms that we're dealing with. Na has a molecular weight of 23, and Cl, chlorine, has a molecular weight of 35. There's only one of them in the formula, meaning 23 plus 35, which equals 58 grams per mole. Okay, so now that we have that, we have all the information that we need. We have the information that we need for our initial equation, which is molarity equals moles over liters. And we have our units for the conversion table that we'll need to change the moles into grams. Okay, now we can start to solve our equation. So we can start by plugging the information that was given to us into the equation that we have to solve for. So we have 0.364 molarity is equal to 0.152 liters, and in moles. Okay, so there are probably two questions that you have about this equation here. Question one might be, where did you get the 0.152 liters, and more importantly, where did you get liters from? The information that they gave us is milliliters. Well, because we know that our equation calls for liters, we have to convert our given 152 milliliters into liters. And I did that with the simple conversion table of 1,000 milliliters equals 1 liter. But you can also use the jump method, and I'll show you both very quickly. Okay, so the conversion table. So in this case, we'd have our 152 milliliters. Place our 1,000 milliliters here, and our 1 liter here. Okay. And then we'd enter it into our calculator. Now, I personally prefer, at least in Casio's, to use the fraction bar to insert the numbers for a unit conversion, just because I think it's easier. It's honestly whatever you want to do, whatever is best for you. This just happens to work for me. Okay, so the number that we get is 0.152. And because milliliters cancels out with milliliters, you're left with liters, 0.152 liters. Another way that you could have done it would have been, you take your 152 milliliters, and you know that there are 1,000 milliliters in 1 liter. So there are 3 tens places that is separating your milliliters from your liters, and you can just be like, oh, okay, 3 tens places, cool, I'll jump that 1, 2, 3, bam. Honestly, I think that this way is convenient, but it can be kind of confusing to me personally, which is why I just prefer the unit conversion way of doing it. Honestly, once again, it's just whatever is most comfortable for you. So, yeah. Okay, back to the original problem. The second question you might have would be, why do you have an N where moles should be? The reason why we have an N where moles should be is because we were not actually given our specific number of moles. However, we were given enough information to be able to find our moles, which will help us subsequently, through the use of unit conversion in our molecular weight, find the mass of NaCl. Okay, so hopefully that answers those questions you might have had. If you have more questions, I am sorry, I guess. Yeah. But yeah. Okay, so moving on. The next thing we would do would be to multiply the 0.152 liters by the 0.364 molarity. Yes, molarity. Struggling to talk. I apologize. Plug it into our calculator. 0.364 divided by 0.152 equals a molar mass of, molar mass, just 2.39 moles. Yeah, just equal 2.39 equals N. So really quickly, we're going to do a little proof that'll explain to you hopefully which unit to put here. This unit is obviously going to be moles because that's what N was supposed to equal to. But I'm going to attempt to prove to you why it is moles. Wish me luck. Yes? Okay. So molarity is just a ratio of moles over liters, which is equal to moles over liters. So basically, when you multiply your liters, you are multiplying the inverse. So here you would technically be multiplying, the inverse. So it would technically end up looking something like moles times liters over moles, because this liters would be over 1. I feel like I'm overcomplicating this, but hopefully, it makes sense, I guess. And then you just kind of cancel that out, because 1 over 1 equals 1, a number over a number equals 1, L over L equals 1. It cancels out, which basically just gives you moles times 1, which is just moles, and then moles equals moles, and that solves out. If what I said is confusing, please disregard. I don't wish to confuse you. That is not my plan. But yes, anyways, back to what I do know, that N equals 2.39 moles. Yes. So we can kind of put here moles, so we don't forget 0.39. Nice. Okay, now that we have found our moles, we obviously now have the answer to our problem, right? It's obviously this, right? Of course not, because we are looking for mass, not amount, not the amount of the substance that we have, but the weight of the amount of substance that we have. Mouthful. So, what we will do now is we will take the molecular weight, 58 grams per mole, and moles, 2.39. Yes. And we will do a unit conversion to give us ultimately grams, which will be our answer for the mass of NaCl. So let us begin. We will start with our simplest units, which would be the 2.39 moles. Okay. Now be sure when you take your molecular weight, or really in truth, anytime that you do unit conversion, you make sure your units cancel. So when you take your molecular weight, it would be 1 mole over 58 grams. Because if it isn't like this, these units won't cancel, and you will end up not with your desired unit of grams, but with moles or some sort of weird variant of grams per mole or moles per gram. You don't want that. So just do it like this and you will be fine. Okay, so our units cancel out. Hopefully, if that little demonstration I gave earlier with the molarity equation made sense, that same thing applies here. It's just when they're like this, you're multiplying the reciprocal by it itself, and it just cancels because magic. Math is magic. Math is magic. Okay, so we have our desired units of grams, and we just enter this into our calculator. So 2.39 times 58. 138.62. 138.62 grams. Okay. Well, and that should be our molecular weight. Now, if you have the time, sometimes you won't, but most times you will, go back and check your problem. And problems like these, where there are two parts, where you have to find a specific piece of information such as your moles to get your answer, because it's not given to you, there is a chance that you could have made a mistake in your calculations and this number could be wrong, which means that ultimately this number may be wrong. So always go back and check. Okay, so we have our equation. Molarity equals moles over liters. And we just kind of insert. So moles over liters, we had 2.39 moles over 0.152 liters. Put in our calculator. The goal is to end up with 0.364 molarity. Okay, so 2.39 over 1.2. Crossing fingers. Ooh, that's not right. Well, okay. Let's go back and see what we did wrong. So, we're going to go back and we're going to look back over this equation. I'm not going to explain it because the steps were correct but the numbers were wrong, so please bear with me. I'm pretty sure, however, that it was a problem with inserting into the calculator, and I will show you what that problem was, which is another great lesson on checking your equation and checking your calculator. Everything you do, double check. Human error, human fallacy can mean points deducted. If you have the chance, check it over. Check, 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 checkity, check, check. Okay, so molarity. Moles over liters. So our molarity is 0.364 equals moles 0.152 liters. Okay. 0. Excuse me, this is my bad. Okay. So, let me show you what happened. So when I went to put this into the calculator, the 0.364, I pressed the divide button. 0.152. To get the 2.39 that we got for moles. This is not right. We multiplied. Dividing would have given us some weird, well, if we had to divide it, it would have been moles over liters squared. That's not what we want. We just want moles. Yes. That's just a whole unit thing that you can use to check your equation if you understand it. If you don't bother with it because you'll just confuse yourself. That's another story for another day. So let's see what we get when we do this correctly. Okay, so 0.364 times the times button, I pressed it this time, 0.152 gives us 0.0553. Okay, so we'll just go with a 0.055. Alright, straightforward. Equals moles. Okay, and then so now that we have that settled, moles should equal 0.055. Go back and do our unit conversion, which again, like I said, was correct in the steps, but the numbers were wrong. We'll start out with our proper numbers. to get that 1 mole. These will cancel out. Mole, yes. And then 58 grams, which is our desired number, grams, to give us 0.55 times 58 equals 3.19. Okay, so we're going to go back and check our moles. 0.055 divided by 0.152. 0.055 divided by 0.152 gives us approximately 0.362. Now this is about 2 numbers off technically, but also you have to remember that we did round this number. This number is not the exact number, but I can go find the exact number. Okay, so this number, the 0.055328, we can take that number, the 0.055328, and divide it by 0.152 to give us exactly 0.364. So this is our mole. These are our moles, and the way to properly check our grams would be to take our grams and just do a reverse unit conversion, remembering that our units should cancel. Grams over 1 mole, which is our desired number, which is our desired unit, and we'll get 3.19 over 58 to give us 0.055. This equation now checks out. Okay, so this is how you solve and check how to find in the mass of NaCl in a solution of 150 milliliters with a molarity of 0.364. Yes. Thank you for watching, and hopefully I didn't confuse you too much.